We're going to continue with the calculation questions in this video, and we're going to stay on moles, but we're just going to look at a different type of question, one that commonly gets asked in the exam. So they've given you a question here. They've said you have 36 grams of magnesium. It reacts with oxygen and it forms magnesium oxide. What is the mass of the magnesium oxide produced? And they give you a balanced chemical equation. All right. When you are asked about the mass of something produced, when you're asked to calculate mass and you are given a balanced chemical equation, then this is when you are going to use your table. And when you are drawing the table, the first thing you need to decide is what you will put into your table. In your balanced chemical equation, you have got three different things. You've got Mg, O2, and MgO, but you're only going to put two of them into your table. Okay? When I read my question, it tells me I've got 36 grams of magnesium. Okay, so it's giving me information about magnesium. So I know magnesium is important, and I'm going to put magnesium into my table. It says reacts with oxygen to form magnesium oxide. What is the mass of the MgO produced? You're being asked about the magnesium oxide, so therefore that is also important. So I'm putting MgO in because I'm asked about MgO. Okay, what is the mass of MgO? I'm being asked about it. And I'm putting in magnesium because I'm given information about it. In terms of oxygen, I'm told magnesium reacts with oxygen, but I'm not giving any more information about oxygen. I'm not given any numbers related specifically to the oxygen. And I'm also not asked about oxygen. So my question is going to focus on magnesium and magnesium oxide, and I'm going to ignore the oxygen. Okay? Once you decide what's going to go into your table, you're going to write the same thing on this side every single time. You're going to write mass, formula mass, moles, and ratio. So the three components of your formula triangle, and it does help to always write them in this order, okay, because then you're just doing the same thing over and over, and then you've also got ratio, okay. So I'm going to start by filling in mass, okay, mass of magnesium. I'm given this in the question, it is 36 grams, so I'm getting this from the question, so I'm just going to put a little Q to tell me that I've gotten it from the question. There was no calculation involved. The mass of magnesium oxide, well, that is what I'm trying to find. That's going to be my final answer. Formula mass, okay, you can work this out using the numbers from the periodic table. And they typically don't even expect you to go to the periodic table. They will give you that information in the question. And they'll tell you that magnesium has a formula mass of 24. And they'll tell you oxygen has a mass number of 16, and you'll use that information to work out the formula mass, okay? So when I'm calculating the formula mass of magnesium, it's just one magnesium, there's no numbers there or any other atoms. One magnesium has a formula mass of 24. With MgO, I've got one magnesium and I've got one oxygen, so it's going to be 24 plus 16, so 24 for magnesium, 16 for oxygen. I add those together and I get a formula mass of 40. Okay, please note when I'm calculating formula mass, I am not using the large numbers from my equation. Okay, and because I'm not using these large numbers from my equation, you'll notice when I wrote magnesium oxide into my table, I didn't bring the number 2 down. And the reason I didn't do that is because when I'm calculating formula mass, if you've got a big 2 here, it's really tempting to do 2 multiplied by 24 when you're calculating your relative formula mass, okay? And you are not supposed to, okay? We don't use big numbers for formula mass. I'm going to underline each of those big 2's in my balanced chemical equation. Underline them. I'm going to write myself a little note. Don't use in MR, which is your formula mass, okay? So I don't use those big numbers when I'm calculating relative formula mass, okay? That's not what they're used for. So magnesium, I've just got magnesium, and then MgO, I've got one magnesium and I've got one oxygen, okay? If you had small numbers in the formula, we'll do another example in a minute, you would use the small numbers, but you never use the big numbers, okay? So I've got mass and I've got formula mass. Now I need to find moles, okay? So this is where you need to know your formula triangle off by heart, okay? So you've got mass, formula mass, and moles, okay? If I'm trying to calculate moles from my triangle, I can see that moles equals mass divided by formula mass, okay? I've got mass, I've got formula mass, so it's going to be 36 divided by 24. And that I think is just 1.5, I'm going to confirm, and that is 1.5. Okay, so I'm doing mass divided by formula mass, and I am finding moles 1.5. Okay, and that, I'm just going to highlight that because that is going to be mark 1. Okay, these are 3-mark questions. That's your first mark there for calculating the moles of magnesium. All right, then I come over to magnesium oxide, and I see I can't do that same calculation. I don't have the mass of magnesium oxide, therefore I cannot find the moles using that same equation. That's when ratio is going to become important, all right? And when you are writing in the ratio, that is when you use the big numbers from the periodic table, from the balanced chemical equation. All right, so there's a big number 2 in front of magnesium, so I put that down here in my ratio. There's a big number 2 in front of magnesium oxide, so I put that down into my ratio box. And this tells me I've got a ratio of 2:2. I can simplify that ratio to 1:1. All right, and what the ratio tells me is that I need the same number of moles of magnesium as magnesium oxide. If these two numbers are the same, then these two numbers must be the same. 1:1. This is going to be 1.5:1.5. So if these two numbers are the same in a 1:1 ratio, then these two numbers also must be the same and must be in a 1:1 ratio. So 1.5:1.5. Okay, and I'm getting these big numbers here from my equation. So I'm going to write that. Don't use in formula mass. I use in ratio. So those big numbers are not used in this calculation, but they are used at the end in the ratio. Okay. I get a second mark for just using the ratio to find the moles of magnesium oxide. Even if it's a simple 1:1 ratio, you'll still get a mark for doing that. And in the final part of your table, you need to fill in the mass of magnesium oxide. If I want to find mass, formula for mass is formula mass times moles. I've got my formula mass as 40. I've got my moles as 1.5. So it's going to be 40 times 1.5 equals 60 grams. And that tells me if I start off with 36 grams of magnesium, I can produce 60 grams of magnesium oxide. And that is my final answer. So you'll notice, okay, that you can divide this calculation up into 3 steps. The first step that we completed, okay, you were dividing, okay, you were doing a simple division, mass divided by formula mass equals moles. Okay, so your first step, you're doing a division, mass divided by formula mass is moles. In your second step, you are using the ratio. So in this case, the ratio was 1:1, so our moles were the same on each side. And then in our final step, step 3, that's always going to be some sort of multiplication. Multiplication, it's not how you spell it. Multiplication, okay? And you're going to be doing moles times formula mass equals mass. So you're going to divide, you're going to use the ratio, and then you're going to multiply. They'll be the 3 calculations. Divide, using the ratio, and multiplying. And they will be the 3 calculations for the 3 steps to get you your 3 marks, okay? I'm just going to change this question slightly just to give you one more example before you do some for yourself. So I'm going to stick with the same equation. I'm going to stick with 2mg plus O2 goes to 2mgO, okay? But instead, this time we're going to look at, I'm going to tell you that you have got 100 grams of oxygen, and I want to know how much magnesium oxide you're producing. Okay, so if you had 100 grams of oxygen and you have enough magnesium, how much magnesium oxide can you produce? So I'm going to do exactly the same thing as I did before. I'm going to start by drawing a table. This time, I'm going to put oxygen in my table, okay? And I'm putting it into my table because I'm given information about oxygen. I'm told I've got 100 grams of oxygen, so oxygen goes in my table. I'm going to keep magnesium oxide in my table because once again, I'm being asked about magnesium oxide. This time I'm ignoring magnesium. I'm not asked about it. I'm not given information about it. I'm not going to put it into my table. The rest of my table looks the same. Mass, formula mass, moles, ratio, okay? The mass of O2 I'm given is 100 grams of magnesium oxide. That is what I'm trying to find. Formula mass, okay, I told you that oxygen has a mass number of 16, and we know magnesium has a mass number of 24, okay? When I'm calculating the formula mass of O2, Okay, I am using the small number. Okay, I never use my big numbers in formula mass, but this small number here that I've got next to oxygen, that tells me I've got 2 oxygen atoms, and I'm going to use both of them calculating my formula mass. So it's going to be 16 plus 16 equals 32. So we're using small numbers in formula mass, we're just not using those big numbers from our balanced chemical equation. For MgO, it's the same as above. You've got 1 magnesium, which is 24, plus the oxygen is plus 16, giving you a formula mass of 40. Then I come down here to moles. Okay, I've got the mass of oxygen, I've got the formula mass of oxygen, so it's going to be 100 divided by 32, and that equals 3.125. 3.125. So just like I had up here, step 1 is dividing, mass divided by formula mass. Here is again, step 1, you are dividing, mass divided by formula mass, 3.125. Again, I can't do the same over here for magnesium oxide because I don't have mass, which is when I'm going to use my ratio. Okay, now in front of O2, there is no big number. And if there is no big number, then I'm simply putting down a 1. Okay, if there's no big number, you put down a 1. For magnesium oxide, again, you do have a big number. You've got a 2. So I put down the 2 for magnesium oxide. So now I've got a ratio of 1:2. And this ratio tells me that I need double the amount of moles of magnesium oxide as I have of oxygen. Okay, so a 1:2 ratio. This number here is double this number here. 2 is double 1, which means this number here has to be double this number here. If I want to double it, I'm going to have to multiply it by 2. So it's going to be 3.125 multiplied by 2 equals 6.25. Okay, so these two numbers, 1:2, this number is double this number. These two numbers here, 3.125 and 6.25, this number is double this number. So they have the same relationship. They both have a 1:2 ratio. Okay, that ratio tells me that I need double the amount of moles of magnesium oxide as I have of O2. Therefore, if I've got 3.125 moles of O2, I need double magnesium oxide, so I need 6.25. Okay, and this is your first mark, this is your second mark. So again, step 1, I was doing a division. Step 2, I was using my ratio. And step 3, I'm going to be doing a multiplication. Okay, I need to find the mass. Formula for mass is formula mass times 6.25. So it's going to be 40 times 6.25 equals 250. Okay, so if I'm starting off with 100 grams of oxygen, I can produce 250 grams of magnesium oxide, and that will be 1, 2, 3 marks. Okay, when you are doing these in terms of numbers of decimal places and all that, I would typically keep all of these answers to 3, if not 4 decimal places, so don't round too soon. Okay, so when you're calculating your moles here, you can keep your answers to at least 3 decimal places, and then your final answer, then you can round your final answer to 1 decimal place or 2 decimal places. Just look at the actual question. Sometimes they will specify whether you should be giving your answer to 1 or 2 decimal places, so pay attention to that. But as you go through the calculation, to keep things accurate, keep your answers to 3 or 4 decimal places. Okay, so I want you to do 2 of these questions for me, or 3 of these questions I think I've prepared. So in your practice booklet, your core information booklet, on page 21, I want you to do questions 13, 14, and 15. And these aren't questions that I've made up. These are questions that are actual exam questions. So you'll notice they has a little bit kind of more information in the question, a bit more kind of added information. So they look a bit longer, maybe a bit harder, but the process is exactly the same. So please do 13, 14, and 15. Press pause, do them for yourself, and then when you press play again, I will go through the answers with you. Okay, so I've done out the answers. Okay, this is number 13. You're given information about iron, you're asked about iron chloride, so they are both in my table. Okay, I worked out the formula mass of iron, 56. Remember, I'm not multiplying by 2 because I'm not using my big numbers. For iron chloride, 56 plus 35.5 times 3, because I've got 3 chlorines. I am using my small numbers, okay, so they should be your formula mass. Once you've got formula mass, mass divided by formula mass is moles, okay. The ratio, my big numbers are 2 and 2. I can simplify that to 1:1, so 0.2 moles is 0.2 moles. Remember, if these 2 numbers are the same, then these 2 numbers are going to be the same. then I'm multiplying 0.2 by 162.5, and I'm getting 32.5. Okay, so I'm doing a division for my first mark, then I'm using my ratio, and once I've got my moles and my formula mass, I'm multiplying those two numbers together to get my final answer. In 14, okay, I am asked about N2. I'm given information about NH3, so they both go in my table. Formula mass, again, I'm using that small number, so 2 nitrogens means 2 times 14 is 28. And for here, the NH3, I'm using the small number, so I've got 1 nitrogen and I've got 3 hydrogens, gives me a formula mass of 17. So I'm not using that large number, I'm multiplying by 2, but I am using that small number 3. I've got 3 hydrogens and 1 nitrogen, okay? Once I've got that, it's going to be mass divided by formula mass. My first mark is always a division. That gives me my number of moles, okay? I then need to use my ratio. There's no big number in front of N2, so I write down a 1. There is a big 2 in front of NH3, so I write that down. So I've got a ratio of 1 is to 2. Oh, sorry, I wasn't given this, was I? Whoa. I was given this. So it was 72 divided by 17. So this is the number that you would have calculated. You're given the 72. I divided by 17. And this here was mark number 1. So that was the division that you were doing. Then you've got your ratio as 2 is to 1. Okay, so you need half the amount of N2 as NH3. Okay, you've got a 1 is to 2 ratio. NH3 has to be double N2, or N2 has to be half of NH3, okay? So if this number here is half, 1 is half of 2, then this number here needs to be half of this number here. So I'm going to take my 4.235, I'm going to divide it by 2, and that's going to give me my moles. Okay, so these relationships have to be the same. 1 is half of 2, 2.118 is half of 4.235, okay? This is my moles of N2, and now that I've got moles, it's just moles multiplied by formula mass, and that gives me my mass. And I think I rounded this slightly different than the answer I wrote in your booklets, okay? But that's going to be number 14, and then number 15, given information about F2, I'm asked about FS6. They both go in my table, okay? This is the mass of F2 that I'm given. They even tell you the formula mass. You don't have to calculate it. They tell you it's 38. So mass divided by formula mass is your moles, okay? Then I'm looking at my ratio. I've got a big number 3 in front of F2, so 3 goes down here. I've got nothing in front of SF6, so I'm putting a 1 here. I've got a ratio of 3 is to 1. This number is 3 times bigger than this number, okay? So this number needs to be 3 times bigger than this number, okay? So to find this number, I'm going to have to divide by 3, okay? If I divide by 3, then this number ends up being 3 times smaller. Okay, so 1 times 3 is 3, 0.0083 times 3 is 0.025. They are in the same relationship. There's the same ratio there, okay? So this is my number here for moles. They give you the formula mass as being 146. So I multiply those two numbers and I get 1.22, okay? And they do specify in this question to give your answer to 3 significant figures. So it's important that you're giving your answer as 1.22 grams, okay? So your mole questions, I'm not going to spend any longer on those. I'm just going to take a minute to go through the concentration questions. Okay, and when you are asked to calculate concentration, okay, they will always ask you for the concentration in grams per decimeters cubed, okay? Gram is a unit of mass, decimeters cubed is a unit of volume. And if I look at this unit, gram per decimeters cubed, it actually gives me the formula, because writing G/decimeters cubed is the same as writing G over decimeters cubed. In other words, mass divided by volume. So they give you the formula that you need to use by giving you the units. And they will give you the units. They'll say, give me the concentration in grams per decimeters cubed. And you can write that as this, gram over decimeters cubed, which means that when they give you the numbers, it's going to be whatever they give you as a mass, whatever they give you in grams, divided by whatever they give you as a volume in decimeters cubed. Okay? Now, typically, what they'll do is that they'll give you the mass, so they'll say, what's the concentration when you dissolve, let's say, 50 grams of sodium chloride in in 500 centimeters cubed of water. Okay, that is a typical question, all right? And they'll say, give your answer in grams per decimeters cubed. Okay, so the first thing I'm going to do is I'm going to take this grams per decimeters cubed, which they've given me in the question, and I'm going to write it as grams over decimeters cubed. Okay, and then I'm going to go back to the question and I'm going to find the number that has a G next to it. Okay, because that's going to be my mass. All right, and I've got 50 G here, so that's my mass is 50 grams. So I plug that in on the top. Then I need to go in and find the number that's written in decimeters cubed. And you'll see that the only other number you're given is actually given to you in centimeters cubed. Now, centimeters cubed is a volume, okay? It's the same as mils, but they're telling you it's got 500 milliliters of water. But you need your volume in decimeters cubed before you can plug it into this equation, all right? So what you're going to do is you're going to take your 500 centimeters cubed and you're going to convert that into decimeters cubed. To convert from centimeters cubed to decimeters cubed, you need to divide by 1000. And when you do that, you get 0.5 decimeters cubed. Okay, now I've got my volume in the right unit. I've got a number in front of decimeters cubed, so I can plug that straight into my equation, and then I can do my division, which I should really be able to do in my head. 100 is 100 grams per decimeters cubed. Okay, so you just need to make sure that you've got one number in grams, so your mass is in grams, and then your second number, it needs to be in decimeters cubed. They'll typically give it to you in centimeters cubed. They'll want you to convert, and then you're just doing your division. Okay, when you're doing your division, because sometimes people get confused, am I dividing or multiplying? Okay, centimeters cubed is the same as milliliters, and decimeters cubed are the same as liters. So if you were going from milliliters to liters, okay, you would need that number to get smaller. If you've got 500 milliliters of something and you want to convert that to liters, 500 milliliters is half a litre. So that number is getting smaller when you go from milliliters to litres, because litre is a much bigger measurement. Okay, if you had 500 milliliters and you wanted to convert it to litres, 500 milliliters does not equal 500,000 litres. Okay, if you're thinking about mils and litres, I think you would see why that was ridiculous. So try and do the same with centimeters cubed and decimeters cubed. Okay, you are dividing by 1000 to convert. Okay, the other thing I'm going to say is the way I've written this here, grams per decimeters cubed, it can also be written as grams dm to the -3. So instead of giving that stroke, that kind of divided line, they'll just write dm to the -3 instead of dm to the 3. Okay, this does not change your calculation in the slightest. It's still exactly the same thing. Okay, these are exactly the same. You're still going to do the calculation. If you're asked for the answer in gram dm to the -3, it's the exact same calculation. It is mass divided by volume. Your mass has to be in grams. Your volume has to be in decimeters cubed. You do that and you get your answer. And these, gram per decimeters cubed, is equivalent. It's exactly the same as gram dm to the -3. They mean exactly the same thing. So your calculation is the same. Have a go with some concentration questions. Okay, remember to convert and then divide. So do questions 16, 17 and 18. 16, 17 and 18 in your revision guide. Press pause, do the answers and do the questions and then press play. Okay, so I've already worked these answers out for you properly. Okay, so in 15, okay, you're given your mass in grams and you're dividing by 0.1. Okay, so I've converted from centimeters cubed to decimeters cubed. Okay, and then I do my division. The same up here, 250 grams is my mass, and I'm dividing that by 0.347 decimeters cubed. Okay, so in the question, I gave it as 347. I divided that by 1000 to get 0.347, and then I'm doing my division. Okay, and the same with the last one, 25 divided by 0.6. So instead of doing 25 divided by 600, I'm doing 25 divided by 0.6 because I'm putting that volume into decimeters cubed before I'm doing my division. Okay, the last thing we need to go over really quickly is empirical formula. Okay, and if I asked you to get, so just a reminder, empirical formula is the simplest whole number ratio of a formula. So I'm going to give you an example. Okay, this is the formula of glucose, and this is what we call the molecular formula. Okay, and what this formula tells me is that I've got 6 carbon atoms in glucose, I've got 12 hydrogen atoms in glucose, and I've got 6 oxygen atoms in glucose. Okay, it tells me exactly how many atoms I've got in a molecule of glucose. That is the molecular formula. The empirical formula is the simplest whole number ratio. And to calculate the empirical formula, you need to find a number that will divide in evenly to all numbers in your formula. So you've got the number 6, the number 12, and the number 6. The highest number that divides evenly into those 3 numbers is 6 itself. And if I divide across by 6, so if I take my C6, H12O6, and divide across by 6, 6 divided by 6 is 1. 12 divided by 6 is 2. 6 divided by 6 is 1. I get a CH2O, and this is what I call my empirical formula. It is the simplest whole number ratio. So you can see in your molecular formula that you've got twice the number of hydrogen atoms as carbon and oxygen. When you calculate the empirical formula, that's even more obvious. You see you've got the same number of carbon and oxygen atoms present, and you've got twice the number of hydrogen atoms present. Okay, so if I were to do another one, H2O2, okay, this is the molecular formula. It tells me that I have got 2 hydrogen atoms and 2 oxygen atoms. If I want the empirical formula, I need to find a number that divides across evenly. Okay, 2 will divide across evenly. 2 into 2 goes once. 2 into 2 goes once. And you get HO is your empirical formula. The typical exam question will ask you to calculate the empirical formula, and they will give you data as opposed to actually giving you the molecular formula. So, for example, in question 19 of your in your core info booklet, okay, you are told that you have got lithium, you have got carbon. No, you're not. No, you are, and you have got oxygen. So you've got a compound that contains lithium, carbon, and oxygen, but they want to know what's the empirical formula. They want to know what ratio those atoms are present in, and they tell you that you've got 14.8 grams of your compound in total, okay? And they tell you that 2.8 grams of that is lithium, and they tell you 2.4 grams of the compound is carbon, and they tell you the remainder of the compound is oxygen. So you've got 14.8 in total, okay? And they tell you 2.8 is for lithium, and they tell you 2.4 is for carbon. So what's left is 9.6. And that must be for oxygen. So you've got this compound, it contains lithium, carbon, and oxygen, and this is the mass of each element that it contains. And it wants you to turn these masses into some sort of formula, okay? So in order to do this, what you're going to do is you're going to find moles, okay? You're given mass, you're going to find moles. Mass divided by formula mass equals moles. Formula mass of lithium is 7, that's the big number from the periodic table. For carbon, it's 12. Big number from the periodic table. Oxygen is 16. Okay, so I'm taking the masses, I'm given these masses in the question, and I'm dividing by big number from the periodic table. Okay, so that's where I'm getting these numbers from. And I'm doing this to convert my masses to moles. Okay, and I get 0.4, and I get 2.4 divided by 12. I get 0.2. And for oxygen, I get 9.6 divided by 16. Equals 0.6. Okay, so I found moles by dividing my mass by my formula mass. Okay, and these 3 numbers that I've got from moles, okay, I've got them here side by side in a ratio. But to be an empirical formula, I need a whole number ratio, and at the moment they all have decimal places. So I need to get rid of these decimal places so that I can write this ratio with just whole numbers. To get rid of my decimal places, I need to look at the 3 numbers and ask myself which is the smallest of the 3 numbers. 0.4, 0.2, 0.6, which is the smallest number? Okay, the smallest number is 0.2. So what I'm now going to do is I'm going to divide everything by 0.2. Okay, that's my smallest number, and I divide everything by the smallest number. 0.4 divided by 0.2 is 2. 0.2 divided by 0.2 is 1. 0.6 divided by 0.2 is 3. Okay, so by dividing by the smallest number, it's the same ratio as what I had up here, but now it's much easier to see. I've got a ratio of 2:1:3, and it's all in whole numbers. I need to convert this ratio into an actual formula. This is your last step. Lithium, I've got 2, so it's going to be Li and a little 2. Carbon, I've got 1, so it's going to be just 1C. And oxygen, I've got 3, so it's going to be like this, Li2CO3, and that is my empirical formula. So you take the mass, you divide by the big number from the periodic table, you'll get the moles in decimal places. To get rid of those decimals, you pick the smallest of the numbers and you divide across by that small number. That will give you a whole number ratio, and then you write your formula. Lithium, you've got 2 of them, so it's Li2. Carbon, there's 1, so it's just C. Oxygen, there's 3, so it is O3. I've done, that is question 19. Have a go at 20 and 21 yourself. Now in 20 and 21, you'll notice that you have been given percentages instead of grams. That doesn't change anything. You use the percentages exactly as I have used grams in question 19. So you'll take your 70, which is the percentage of iron, and you will divide it by the formula mass of iron, which I haven't given you, but it is 56. So it's going to be 70 divided by 56. And then it's going to be 30 divided by the mass of oxygen is 16. And then you'll do everything exactly the same way. Okay, in 21, it's the same idea. You're given percentages instead of grams. Okay, but you'll do your percentage divided by, and I have given you the formula masses here, percentage divided by the formula mass to find moles, then simplify that ratio. Okay, so again, for 20, I haven't given you the formula mass, but iron is 56, oxygen is 16. So use those numbers to work them out. Okay, so I'm going to go through the answer, which is actually a little bit harder than I intended it to be. Okay, so I'm starting off with my percentages. I divide by 56, that's the big number next to iron on the periodic table, with oxygen's 30 divided by 16. And I get 1.25 and 1.875. So I've got my moles, but I've got decimal places that I need to get rid of. 1.25 is smaller than 1.875. So I divide both numbers by the smallest number, which is 1.25. 1.25 divided by itself is 1. 1.875 divided by itself is 1.5. So you'll see after doing this division, unlike in the previous question, I didn't get rid of my decimal places, okay? I still have 1.5. Now, if that had been 1.9, you could just round it up to 2. Or 1.1, you'd round it down to 1. But when it's bang in the middle, 1.5, you can't round up or round down. But you still need to get rid of that decimal place, okay? And if I need to get rid of that decimal place and I've got 1.5, I've got 1.5, if I need to make a half, a whole number, I need to multiply by 2 because 2 halves are a whole. So I'm going to multiply everything by 2 so that the ratio stays the same. 2 times 1 is 2, 2 times 1.5 is 3. So I've multiplied by 2 to get rid of the decimal, but I multiply both numbers by 2 to keep the ratio the same. The ratio of 1:1.5 is the same as the ratio as 2:3. The iron is then Fe2, the oxygen is then O3, and you get Fe2O3 as your empirical formula, okay? And I'm multiplying by 2 here because 2 halves make a whole, and I need it to be a whole number. The next one is a similar situation. You've got sodium, boron, and oxygen. I take my percentages and I divide by the formula mass that I'm given in the question, and I get these numbers here for moles. Of these 3 numbers, 0.99 is the smallest, so I divide everything by 0.99, and I get a ratio of 1:2:3.5. Yet again, I have got a 0.5 in my answer, okay? I can't have a decimal in my answer. Okay, once again, 3.5, if I need to make a half a whole number, I multiply by 2. But if I'm multiplying 3.5 by 2, I need to multiply everything by 2 to keep that ratio the same. So I multiply all of these numbers by 2 and get a ratio of 2:4:7, which gives me Na is 2, so I'll write a little 2, B is now 4, O is now 7. My empirical formula is Na2, B4, O7. 7. Okay, so that is empirical formula. If you've got any questions on any of the calculation stuff, just message me on Teams.